Yes, so for session one, the name is Big Picture. So let's start this. We have 4 companies here, MediQuant, Fujifilm, Wasabi, and Arcitecta. And I wish to introduce Dr. Kel Pultz, Chief Clinical Officer and VP Government Strategy at MediQuant, to present a data management program. Kel, your turn now.
Thank you, Philippe. Good afternoon. I'm going to follow on a little bit with Philippe's message today. He did mention the necessary need to prepare. You're going to be doing a lot of different steps, making decisions. And one of the things that is really important is actually getting into preparation for a successful program. So it's not just getting in the program, it's actually having a success at the end. So we're going to jump right in. I've got 10 things to keep you or to make you successful in your data management program. The first thing is really getting in the right state of mind. So over the years, we've individually had projects and we've been in a project state of mind. So in this sense, when you're starting to build it with as much data as we have nowadays, you're going to prepare your mind instead of thinking we have an archive project, think we are working on a data management program. Program is a long-term solution. It's not a one and done type thing. It's more than just archiving a specific amount of data. We're talking security, regulatory requirements, long-term storage, and then determining within your own organization, what does success actually mean to you? What do you need to use the active archive for? Second is to plan. So you want to include this program in your budget when you're moving to a new system well in advance, or whether you're just creating a new system, developing a new system. Plan in advance. Don't think that the archiving section is something that you can do as an afterthought. Plan it in your budget early so that you can make sure that it's covered and you're not cutting corners later on down the road. Number 3, select your archive team and your vendor. So experience does matter. You've got subject matter experts on both teams, both in-house and any vendor that you might use to assist you with your program. Make sure that you're actually dealing with subject matter experts. That means if, for example, you're dealing with clinical data, make sure you've got clinicians. If you're dealing with financial, make sure you've got financial people. Video, you've got video experts that understand the type of data that they're actually working for or working with. Very important. Your vendor, part of what the vendor will do is help drive your program and plan. So this is part of the experience. You don't want to be sitting across the table from your vendor and the vendor saying, okay, what do you want to do next? You need somebody that's going to be an expert and help you drive your plan to success. Think adoption and change management early. So at the very end of your program, what you want is you want people using the data. You want that program to be working. How do you get that into and change the state of mind of your organization? So think of these types of things a little bit early. Who's doing what? Who in your organization is going to be participating on the plan or in the program, and who from a vendor perspective is going to be participating in the program? Get people in alignment so that you have a clear understanding of who's doing what tasks. Some of the next few things that I'm going to mention, 4 through 10, some of them can be done simultaneously. And some things, depending on your organization, you may flip some of these tasks, but the point is to make sure you have all the tasks on your list and that you're covering them all, or you've accounted for them as you plan. So completing an inventory of what you have. This is something that we've certainly found that a lot of people don't have, especially if you're in a merger and acquisition scenario. There's a lot of that going on in healthcare, which is the space that I'm in particular, but this is happening in other organizations as well. Determining what sites are involved. So it could be many different locations, many different sites. You may have a centralized or a decentralized infrastructure. So you need to kind of determine where all of the data is actually sitting, what applications are sitting out there, software and hardware. It's important to understand where your hardware is as well and what stage your hardware is in. You may have vulnerabilities out there on certain hardware that you're not sure of, especially those legacy systems that you're talking about doing some active archiving with. So that helps you kind of prioritize how you actually want to roll out some of these systems that you're going to put into your active archive. Does it contain PHI or PII? Special regulatory requirements around those things. Look at images. What kind of images are they? Do you have something? Do you have a DICOM viewer? Do you have something that's going to open those images when you need them, or do you need to make sure that your archive contains something like that? Any audio storage, audio, video, images, those types of things obviously take up more storage space. So think about what you want to store those types on. Philippe touched on several different types of storage media. You're going to want to think about those types of things and what you're actually storing as you start put your plan together. Number 5, create a bucket list. Not that kind of bucket list, but the kind of bucket list where you take all of your data and you say, okay, I'm going to put these data elements in buckets. Some of it's going to be regulatory. I have to do certain things with it. Some of it is just research. So for example, maybe you want to de-identify some data for clinician use, but it's going to be used for research. Release of information, patient records, analytics. There are a lot of analytics going on with AI out there. So you want to make sure as you think about AI and Active Archive, how you're going to store that data. Does it need to be on a separate server, for example, especially if you're looking at something like patient data? Interoperability. Do you need to be interoperable? Health information exchanges or other approved organizations, are you going to be sharing data? We have some healthcare organizations that share data with other healthcare organizations out of the country. So there's extra security parameters around that type of thing, especially when they're doing research. Next, Rich. You're going to rationalize, once you've got things into these different types of buckets, what kind of data you have, rationalize it. Is it something you need to keep? What is your reasoning for keeping the data or keeping it in a certain format when you're storing it? So as you look at the different media types, some are going to be cold storage, some are going to be, they may be glass, they may be long-term, they may be different media types, but really you want to know as your rationalization exercise, how often are you going to access the data? Do you need it right now? Is it something that you can query? And you don't need to have it online, we call hot, immediate access for use and viewing. Are you going to look at a hybrid solution? Where are you going to put it? How do you envision your data storage? Is this something that you want to put in the cloud? Server farm, hybrid, disk, tape, glass, etc. And of course, the use of AI will determine if you're going to need to have access to that data on a regular basis, what you're going to use it for. Number 8, determine access requirements and user needs. So who needs to be looking at this data? If you have a requirement for it to display, that's hot, immediate access, then your users are going to need to be able to quickly get to that data on request. So it's not just about storing the data, but it's how quickly can you access the data when you need the data. So those are questions that you're going to need to think about. Medium, occasional use, so you can query the data, pull up some results later. This may be something that's just used for research, or cold, long-term query only. This specifically, researchers love the long-term storage. They can get in there and they can query it. Just think about the format that it's stored in. When you start writing queries or you start using technology to query that data out of there, make sure that you've got the right tools, but think about this early on. Number 9, initiate your program. So in reality, you've initiated the program early on overall, because you're thinking about all of these things, what's going to be included in your data management program. But there's going to be a point where you say, okay, we've got all of our ducks in a row, and now we're going to kick off this program. So it's kind of a kickoff. You're going to monitor the outcomes. You're going to monitor the quality of the data, pivot if you need to pivot in the middle of your project. If you notice right off that you need to pivot and do something a little different, then do it early. It's better to do it quickly, save money, and make that pivot if you need to reach your success goals. Evaluation, you're going to evaluate throughout this process. From the beginning, you're going to evaluate, you're going to question, the team's going to question. Make sure that you are evaluating your own self when you're looking at your program here. Are you making the right decisions? Why are you making the decisions that you are? Is it a financial reason? Is it a technology reason? Are you covering all your bases? Are you making sure that you've got data accessible to specific people that need it when they need it? If you've cut corners somewhere, be evaluating that to say, what are the long-term effects of us cutting corners on something? Make sure that you've really thought through your process and evaluate your progress as you move along. Part of what you're doing on your evaluation is you're evaluating whether or not you're on target with what your vision and your goals are for your own organization. This is an ongoing process. Even after you've completed your initial program, this is a continuous thing because data continues to grow, as everyone knows, and you're going to continue this program management process of data. It's not going to be a one and done. Think the long term of what you're going to do with data and how you're going to continually move that data to whatever storage and access points you need it. Finally, the last slide, let's talk about just some of the major keys to success. Prep and planning. At the very beginning, when you're thinking about your prep and planning, and I talked about the use cases, are you going to need to use AI in your active archive? Today, absolutely. Your researchers are going to use it. It's going to help you move the data. It's going to help you organize the data. Organization and the learning curve. These are changes for people, right? These are going from individual projects and data sitting everywhere to determining how you're going to get your data into a management program that's going to be long-lasting and sustainable. That's one of your big goals, is you want it to be sustainable, flexible, and you want to make sure that it's scalable. In today's market, data increase and just the amount of data that's coming out daily, any solution that you think of needs to be scalable. And again, that flexibility is going to make sure that if you need to pivot and you need to make some changes to your program, that you've thought about those concepts. Initiation and rollout, make sure your team's together, make sure you've got the right people at the table, be prepared for your rollout. Know that everything is not perfect every time, that you're going to run into things. There's all kinds of surprises that you find in legacy data, but they're not insurmountable. Monitoring and the ability to be flexible. Again, be prepared to pivot if you need to. Flexibility, rearranging projects if you need to, moving certain data elements or projects, individual projects up in your program queue. Whatever you need to do to kind of roll these out. Perseverance and communication. Again, this isn't an easy thing. You may come up on things where you have to stumble, but you've got to communicate with your teammates, communicate with your vendor, and communicate with experts across the industry. There are new things coming out. This organization, the Active Archive Alliance, is a great forum to talk about the new things that are coming out. We've got a lot of companies here that do different types of media storage for Active Archive using AI. And so being able to reach out to industry experts across the aisle, even if it's not in your own field, and talk about some of these things that you're coming up against can help you persevere. And then, of course, celebrate successes along the way. Make sure that those little ones, the individual things that you do, you're succeeding and that you're celebrating those. This is a long-term program, not just an individual project. And so make sure you're celebrating those successes as you move along. And Rich, I will turn it back to you. Oh, sorry, Philippe, I will turn it back to you.
Good. Thank you, Kel. Now, let's continue with Rich Gadomski, Head of Tape Evangelism at Fujifilm, to cover some AI costs with Active Archive. Rich, the stage is yours.
Yeah, thank you very much, Philippe. I just wanted to touch on briefly, how to reduce AI-related costs with Active Archive. And, it's a big issue. Corporations and organizations are going to be spending upwards of $1 trillion, according to research. So in this visual, you see in the blue bars, total IT spend on AI technologies. And on the right scale, it's percent of total technology spend as a percentage. So what this research is suggesting is that we are going to be going from 3% of IT spend in 2024 to 12% of IT spend by 2032, just on AI technology. So this is going to change fundamentally how IT operates. And we believe that something is going to have to give. And organizations will want to find ways to offset this increasing expense. And we think storage will be one way that they can do that. So we know that in the AI workflow, it requires an incredible amount of data, and therefore multi-petabyte storage, even exabyte scale storage is going to be required. So as new data comes in and is typically staged on high-performance storage, but as it goes through the workflow, it needs to reside long-term in Active Archive and cold archives. Otherwise, the cost of that storage will be cost prohibitive. So Active Archive can leverage low-cost tiers of storage whether that be tape, economy disk, optical technologies, or even cost-effective cloud options from innovative vendors like Wasabi, who we have here today. So in this last visual, this is showing a 5-year cost per terabyte trend. So in the dark blue line at the top, that's 5-year cost per terabyte for SSD systems. In the red is high-performance HDD systems, 5-year cost per terabyte. And the lower line in the light blue is typical cost for active archive systems, 5-year cost per terabyte. Now, this is a log scale, so the differences are actually more significant. But according to John Monroe and Brad Johns in their recent study, The Sustainable Advantage of Enterprise Data, they find that active archive technologies, due to their low energy consumption, removability, can significantly save compared to high-performance storage. So by 2035, for example, active archive technologies would be 8x more cost-effective than HDD, or 33x more cost-effective than SSD systems. So we need SSDs, we need HDDs, but the fact is that as the data goes cold or is infrequently accessed, yet must be retained for many decades, especially to support future AI activities and reanalysis, it makes sense to move that to cost-effective solutions like active archives. So that's what I wanted to share today, and I'll turn it back to you, Philippe.
Good, thank you, Rich. I really appreciate your last slide to put things in perspective with the cost trajectory. Third presentation with Wasabi and David Boland, Vice President Cloud Strategy, speaking about understanding the active archives role in an AI data pipeline.
All right. Thank you, Philippe. Rich, great job. I'm going to pick up where you left off. You mentioned AI workflows, and I've got a couple slides that point out an AI pipeline and where the different types of storage sit in those. So if we'll move to the next slide, we can illustrate to the audience the different types of AI workloads that are out there today. And boy, there's a lot of them. There's been lots of news in the last few years about generative AI, but there's more than just generative AI out there. Although there's a lot of excitement around Gen AI, it's not just the only type of AI out there. So it's important to remember too that there's not just a single type of workload that we're talking about. It could be a ton of different things, from conversational user interfaces to perception. That's object detection, recognition, and analysis. There's autonomous systems that we see coming to market very soon. If they're not already here, we know that there's some self-driving cars in Arizona, in the USA today. There's advanced robotics and drones, all running on AI. There's knowledge discovery, as Dr. Poltz mentioned, in the medical world and life sciences. There's a knowledge store, there's search, there's mining data, there's association detection in case of knowledge discovery, segmentation and classification as well. There's object classifications, clustering, customer segmentations, predicting and forecasting is critically important. Recommendation systems. Every time I go on Amazon, they recommend a new purchase for me based on my prior purchases. And there's content generation, which we talked about just a moment ago, generative AI and AI applications. There's a bunch of different systems out there, but what's interesting is all of these use cases have something in common called a multi-step pipeline. And we'll go to the next slide, Rich. Each step in this multi-step pipeline requires a different type of data format, different types of runtimes, and typically different types of hardware, both compute and storage. And of course, we're all talking about active archive today, so I'll focus more on the active archive in a moment and the ingestion of the raw data. But the pipeline really flows from left to right and then back again on the archive side. And in each one of these stages, you can see different requirements for different types of storage and different types of compute. At the data ingest stage on the far left-hand side, this is where we gather the raw data, such as images or time series data that's used to create and refine the model or as inputs to the decision process. So all the raw data is ingested from multiple sites. Consider this really more of a media lake, data lake on the left-hand side. It all gets stored there on its way to be pre-processed and transformed. This transformation or pre-processing or preparation stage is really where the raw data needs to be cleansed and prepared. And before processing, this is where we take, let's say, images or any kind of content, turn them into embeddings, and then put them into the training model, which is, of course, the third stage here. And this is a stage where it could take weeks or possibly months to train a model. The data is loaded and iterated many times here. It's validated against known correct data to make sure that the output is accurate. This is where we see maybe more high-performance file systems in the model training space and the validation space. And then lastly, of course, there's production deployment. And this is where AI can be deployed for use. And critically important, and as I mentioned earlier, is the archive stage for data input and for data auditing and compliance. And depending on which industry you're in, if you're in the medical device space or life sciences space, they may require logging every AI decision that's made, along with the input data and the model information. For example, an image recognition system may require you to register the output as well as the original images that were used to create that output, and as part of a recommendation solution. So that there's an audit path. So from working from left to right, we have the raw data, your transform data, which could be high performance file systems, your model training, your validation. This is where your vector database may sit. We'll talk about that more in a moment. That's typically where you find your CPUs and your GPUs and the model training and validation side. Product inferencing, you need some speed there, so it could be CPU memory there as well. But then everything goes back into the archive, which it could be tape, could be ceramic, it could be glass, it could be spinning disk. As Rich said, this could be an expensive process. So therefore, you want to make sure that you're using the right storage at the right stage in order to use your finances wisely. Next slide, please, Rich. Awesome. So, like I said, each of these stages have a unique set of capacity, throughput, and latency requirements. What we focus on here is that raw data and archive solution for, in our case, Wasabi, a combination SSD and HDD. And we have a customer currently using Wasabi for the stage that has. They're storing 6 petabytes of data and about 30 billion images for their object recognition solution. And what they'll end up doing is every 18 months or so, they will train a new model. There's constant iteration and fine tuning going on throughout the pipeline, but every 18 months or so, 18 to 24 months, there's a whole new model gets trained. And the reason why they train these models on a regular fashion is because they can make them more efficient, less expensive, and increase the performance on the inferencing. So in order to do that, what they'll do is they'll store all their raw data, and then they'll egress it out to their compute partner of choice, and then run a new model, archive the old models for compliance reasons, and then set up the new model for production use. So when you have 6 petabytes and 30 billion objects, and you have an AI application that you're bringing to market, you need to look for specific storage features and functionality at this stage in the pipeline, and they're looking for scalability. Obviously, object storage, S3 storage has exabytes of scalability. It's readily available. 4 nines of availability and 11 nines of durability typically are seen as the baseline. Secure object storage is secure for this. Performant, absolutely quick response times, resilient and simple. The easier it is to make, I think Dr. Pultz mentioned it earlier, the easier and simpler it is to deploy, the more success you're going to have on it. So so each stage, again, has different requirements and different performance needs. When you're at the ingest stage or the archive stage, you want to look at what those functions are for storage, because they're going to be a lot different than the model training and validation. And so hopefully I touched upon everything that I had in mind. And if not, I'll be around for questions later. I'm going to kick it back over to Philippe and we can move on. Thanks, Philippe.
Thank you, David. Interesting presentation. And last speaker for this first session is Eric Paulette, Director of Product Marketing at Arcitecta, speaking about AI optimize active archive integration.
Awesome. Thank you, Philippe. And thanks all the previous speakers, because you really did touch on a lot of the things that make an AI workflow possible. We talked about how quickly you can get your data. Celebrating successes, I think, is one of the key things that Dr. Pultz said. This is a new technology. This is groundbreaking. Don't get caught up with perfection. Celebrate the successes that we had. And as we look at how we can optimize an archive, how we can optimize data for active archives, we're really referring to minimizing training delays, improving model accuracy. Just having vast amounts of data doesn't help any AI initiatives. If you can't find and utilize the data, make it efficiently available, the AI strategy workflow just doesn't operate. There are too many delays. So by picking a solution that uses a metadata-rich search, AI-powered tagging, really enabling quick discovery and relevant data, this is critical in selecting how to deploy an AI strategy for your organization. In the next slide, we look at how AI training and data sets really kind of take off and what's needed. And there's pretty much two different types of key data that you need. The training data sets. This is going to be the large volumes of data used to train the models, feed in the AI beast and keep pumping in data. The second part, which is really key, is the inference data set. This is going to be a smaller data set, more real-time data that's used in AI predictions. When you can train your data set and then interweave inference data sets, that's really where you can get a lot of the value out of AI and optimize it. And so then when we look to how we can get to a faster AI inference and look at some smart caching on the next slide, we can really see that a complete data management software is able to enable faster AI inferences. We will be capable of predicting AI access patterns, preloading critical data into fast storage, and reducing latency, ensuring that real-time AI performance is at its peak. When we're dealing with AI optimization, it really always comes down to how fast and how efficiently can you feed the AI machine the relevant data, and picking up a solution that can reduce delays and get you results faster. Again, go back to some of the previous things that we've talked about, and we hear moving data to different storages, getting the active data up to the hot tier, and finding a solution and a software that can make those decisions and leverage the insights in the AI training to make informed decisions about your data. Stage the appropriate data when you need it. That's what could optimize your AI workflow. And with that, we'll kick it back to Philippe, and I believe we have a little Q&A session now.
Yeah, thank you, Eric. I like your generated image with AI, because I think you use several of them on your different slides.
Yeah.
Yes, I have a few questions, but to stick on the agenda, we'll probably use only one for this time. We have one regarding the cost per terabyte of active archive. The reason why it tries in 2025.
I'll jump in real quick. Cost terabyte, there's That's a tough question because depending on which vendor you're looking at, the costs are going to be all over the place. Of course, Active Archive tape has a really fantastic cost per terabyte option. Followed according to Rick's charts, just above that would be HDD, and then SSD above there, and then CPU-based memory or systems-based memory is probably the most expensive, especially when you're feeding a GPU. But depending on, and I'll take this from the cloud storage vendor perspective. Typically you can get anywhere between $7 a terabyte and $23 a terabyte, depending on which cloud storage vendor you're using. And although that's a really good cost, or that's a big range between $7 and $23 a terabyte. However, what you also want to look at are the costs that may be hidden in there. So it's not, when you're using the cloud, it's not just going to be for storage capacity. There are ancillary fees for API puts and gets and inventory lists and anything you want to do from an operations perspective. If you want to transfer data out of a cloud provider, a storage provider, into a CPU or a GPU provider, there may be charges associated with that. We've seen that close to half of a customer's bill could be non-storage related fees just for transferring data and for API puts and gets. And if your AI model has billions of objects and you're paying a put charge for each of those objects as it goes into a cloud service provider that charges those billion for you to put those billions in there, there's going to be thousands of dollars associated with that as well. So long story short, Philippe, the SSD pricing is still expensive, especially in a cloud provider space. HDD is coming down, and the range could be, from a storage perspective, between $6 to $7 a terabyte and $23 a terabyte, US.
Okay, Kel, you want to add something before we start the session 2?
Not on this particular one. I know we did get another question
Okay.
there, Philippe, that is probably more directed to mine, if you'd like me to respond to that one really quick. It's related to,
Yeah.
you want to read
Yeah,
through a
sorry.
question? Okay.
Sorry. You see the questions. I don't see any.
I can jump in
longer
there,
the
Philippe. It
question
was,
for any
when should
reason.
rationalizing take place? It's the best practice to make it an evergreen process. And if not, is there a good cadence for review?
Thanks, Eric. So I respond to Matt that rationalization should take place after you have an inventory. As you're gathering your inventory, you can actually start rationalizing it. If you've got a lot of it, you're going to be gathering that information. As you start putting together your inventory, you're going to recognize that some things are requirements for regulatory compliance. And those particular ones going to go in those buckets we're talking about, because you're going to do some further analysis on those particular ones. For example, if you're collecting healthcare data, what are the requirements for adult data versus pediatric data? The financial components of it. There are new laws out about not just retention, but how you actually track who's accessing that type of data. New things coming out this year, even around HIPAA requirements, information blocking, those types of things. So you can actually, you can make it an evergreen process. I don't know that it's best practice necessarily. It depends on your area of data storage, what you're actually storing. But in healthcare, continuing to make an inventory and then keeping that inventory up, that seems to be one of the things we notice, is that people will do an inventory and they think they're complete. But it's a constant upkeep. Things you're going to get rid of, things you're going to acquire that are new. You may decide you want to purge some data as things are regulatory. This is always a debate between researchers and providers, for example. So those are some of the internal decisions that you're going to make as an organization. But I know that there are several folks on here that talk about doing an inventory and keeping track of the inventory process as a long-term solution as well. You want to make sure, again, this is your program that you're talking about. So an inventory and managing your inventory is a cost-effective method that adds to your program value.
Good, thank you very much.